Good morning, my dear students. We will continue with the remaining problems of exercise 7.2 on integration from NCERT textbook in this particular video presentation. The 21st sum goes like this: integral tan square 2x minus 3 dx. This can be written as secant square 2x minus 3 minus 1 dx. Can be written as integral secant square 2x minus 3 dx minus integral dx. Then multiply and divide by 2 secant square 2x minus 3 into 2 dx minus x plus c, which will be half integral secant square 2x minus 3 d of 2x minus 3. Only for the first integral I have, which is half integral secant t dt minus x plus c, where secant square t, where t is 2x minus 3, which is tan t by 2 minus x plus c, tan t minus x plus c minus x plus c, which is nothing but tan of 2x minus 3 by 2 minus x plus c. You can even do it as a direct formula, tan 2x minus 3 by derivative of 2x divided by 2. In the derivative I will have into 2, therefore in integration divide by 2. That also is allowed. Since it comes under substitution method, I am doing this method. I repeat, tan square 2x minus 3, I write it as secant square 2x minus 3 minus 1. I make it into two integrals. Integral secant square 2x minus 3 dx minus integral dx. Multiply and divide by 2 here, because derivative of 2x minus 3 is 2 dx. d of will be 2 dx. This 2 dx is replaced by d of 2x minus 3. Replace this by t. Half integral secant square t dt minus x plus c. Integral dx is x anyway. It's carried over here itself. Integral secant square t dt is tan t. Tan t by 2 minus x plus 3. Therefore, tan 2x minus 3 by 2 plus c is the final answer. That will be the final answer. I think it is clear. Then integral secant square 7 minus 4x dx. Just multiply and divide by minus 4. Secant square 7 minus 4x. Secant square 7 minus 4x into minus 4 dx. Secant square 7 minus 4x. Secant square 7 minus 4x into minus 4 dx can be written as minus 1 by 4 secant square 7 minus 4x d of 7 minus 4x, which will be minus 1 by 4 integral secant square t dt, where my t is 7 minus 4x, which is minus tan t by 4 plus c, which is minus tan 7 minus 4x by 4 plus c is the final answer. Let me just redo once again, check once again. Integral secant square 7 minus 4x dx. Derivative of 7 minus 4x is minus 4. For multiply, it will be minus 4 in the second step. This minus 4 dx can be replaced by 7 minus 4x. d of 7 is 0. d of minus 4x is minus 4 dx. Replace this by t. Minus 1 by 4 integral secant square t dt, where t is 7 minus 4x minus tan t by 4 plus c minus tan 7 minus 4x by 4 plus c will be the final answer. This is my 22nd problem. Now 23rd problem. It is integral sine inverse x dx by root of 1 minus x square. Let me just group dx by root of 1 minus x square. Let me just group dx by 1 minus x square. This will be sine inverse x dx by root of 1 minus x square. Can be written as sine inverse x d of sine inverse x, which is integral t dt, where my t is sine inverse x, which is nothing but t square by 2 plus c, which is sine inverse x the whole square by 2 plus c. Let me just recall once again. Sine inverse x dx by root of 1 minus x square is the question given to you. I will group dx by 1 minus x square. So dx by root of 1 minus x square, Now the third step I will write it as integral sine inverse x d of sine inverse x. Then Sin inverse x is replaced by t. Now for integral t dt, where t is sin inverse x, which is reduced to t square by 2. Therefore, which is anyway finally sin inverse x the whole square by 2 plus c. Remember carefully, it's a special symbol, inverse symbol. Therefore, I should not take this 2 inside. Okay, it should be simply written as sin inverse x whole square. I should not take sin power minus 2, something like that. That is wrong. That is wrong. That is not the way I should write. Remember carefully. Sin inverse x is a special symbol for inverse of sine function. Special symbol. Therefore, I should not take this power 2 inside. I should simply write it as sin inverse x the whole square by 2 plus c. That will be the final answer. That will be the final answer. Okay. Now, you mean to say the 24th sum goes like this. He says integral 2 cos x minus 3 sin x dx divided by, this is given as 6 cos x plus 4 sin x. I'll be able to take 2 as common in the denominator. I mean to say 2 cos x minus 3 sin x numerator as it is divided by 3 cos x plus 2 sin x. You should have a clear observation. Derivative of 3 cos x is minus 3 sin x. Derivative 2 sin x is 2 cos x, which is there in the numerator. Therefore, I can very well write this as d of 3 cos x plus 2 sin x divided by 3 cos x plus 2 sin x. It's so the form half integral dt by t, where my t is the denominator 3 cos x plus 2 sin x, which will be half log mod t plus c, which is half log mod 3 cos x plus 2 sin x plus c. Let me just repeat once again. I'll take 2 as common from the denominator. It becomes half integral 2 cos x minus 3 sin x dx by 3 cos x plus 2 sin x. I'm taking the common factor 2 as out from the denominator. Derivative 2 sin x is 2 cos x. 3 cos x is minus 3 sin x, which is there in the numerator. Now for numerator can be written as d of the denominator. Whenever I have d of multiply dx, remember that particular simple rule in our mind. It's easier for us to make it and keep it in our mind. It's the form dt by t, where t is my denominator. Integral dt by t is log mod t. Now for half log mod 3 cos x plus 2 sin x will be the final answer. That will be the final answer. Okay. Then now the 25th problem, it goes like this. Integral dx by 1 minus tan x the whole square into cos square x. Cos square x is written at the beginning, it doesn't matter. Taking this to the numerator, secant square x dx by 1 minus tan x the whole square. But if you observe carefully, d of 1 is 0, d of minus tan x is minus secant square x. Therefore, multiply 2 minus signs in the next step. Secant square x dx divided by 1 minus tan x the whole square can be written as 1 minus tan x to the power minus 2 d of 1 minus tan x. I'll be able to write d of 1 is 0, d of minus tan x is minus secant square x dx. Replace this by t power minus 2 dt, where my t is 1 minus tan x. Therefore, this will become t power minus 1 by minus 1. Already there is a minus sign, which is reduced to 1 by t plus c. This is 1 by 1 minus tan x plus c is the final answer. Let me just recall or redo once again or check once again. This cos square x is taken to the numerator, secant square x dx. But I should observe clearly d of 1 is 0, d of minus tan x is minus secant square x dx. We multiply 2 minus signs in the third step. This minus secant square x dx can be written as d of 1 minus tan x. This is taken to the numerator, 1 minus tan x to the power minus 2. It's the form minus integral t power minus 2 dt, where t is 1 minus tan x. Integral x power n dx is x power n plus 1 by n plus 1 whenever n not equal to minus 1. Therefore, here I apply the same formula t power minus 1 by minus 1, which gets reduced to 1 by t. 1 by 1 minus tan x plus c is the final answer. That is the final answer. That is the final answer. Okay, let me try to do one more problem also, because it's only 10 minutes here. I'll try to accommodate one more problem also here. The 26th problem goes like this. Integral cos root x by root x dx. Just apply t is equal to root x, which is x power half. Now dt becomes half x power minus half dx, which implies dx by root x happens to be 2 dt. Therefore, integral cos root x dx by root x will now become cos t 2 dt, which is 2 sin t plus c, which is 2 sin root x plus c is the final answer. Let me repeat. And taking t is equal to root x, write it as x power half. Dt is half x power minus half dx. Our dx by root x will become 2 dt. Now for coming back to the original integral cos root x dx by root x can be written as cos t 2 dt. This is my t anyway. And for integral cos t is plus sin t. Derivative of sin t is cos t. Therefore integral cos t is plus sin t. Therefore 2 sin root x plus c will be the final answer. 2 sin root x plus c will be the final answer. 2 sin root x plus c will be the final answer. Anyway, rest we'll discuss in the next video. Thank you students for patient watching.